Hello friends, in this video I'm going to teach you how water acts as an acid as well as base. I will explain water as an impurity compound, or how water acts as an acid as well as base through an important theory which is also known as Lowry-Bronsted theory. This was a theory established in 1923 by Sir Nicholas Bronsted and Martin Lowry to explain different acids and different bases. I will explain shortly Lowry-Bronsted theory and then we will focus our main topic. According to Lowry-Bronsted theory, acids were categorized as those compounds which have the ability to donate or to give away its proton to somebody else or to some other compounds or substances. Generally, Lowry-Bronsted acids were called as proton donors or proton givers. And according to the same theory, bases were called as proton acceptors, or those substances or compounds which have the ability to receive proton from other substances and compounds. I made a simple hypothetical diagram so that I make Lowry-Bronsted theory more easier to understand. There are two persons in the diagram, a man and a small child. This man has proton in his hand and this small child has deficiency of proton. He has no proton in his hand, so that he is very upset. Now this man decides to give away its proton to this small child to make him happy. This man now is called Lowry-Bronsted acid because he is giving away its proton to a small child. This small child is known as Lowry-Bronsted base because he is receiving proton from somebody else. Now I will explain how water is acting as an acid as well as base through different reactions. Water is acting as an acid as well as base due to its unique structure, and its unique structure consists of two hydrogen atoms and two lone pair of electrons. Whenever water molecule wants to become an acid, it releases its hydrogen atom in the shape of hydrogen ion, and whenever water molecule wants to become a base, it receives hydrogen ion or proton by sharing one of the lone pair of electrons with it. In the reaction number 1, hydrogen chloride or hydrochloric acid is reacted with water molecule to form hydronium ion and chloride ion. Whenever hydrochloric acid comes in contact with water molecule, this water molecule comes in contact with this proton released by hydrogen chloride. Because water molecule has two lone pair of electrons, so it can make a bond with proton by sharing one of the lone pair of electrons with this proton. So after making a coordinate covalent bond with proton, the structure becomes like this. This structure has one positive charge. This charge appears on the whole hydronium ion because a positively charged particle is being added to a neutral molecule of water. Now in the reaction number 2, I will explain that how water is acting as a Lowry-Bronsted acid. In the reaction number 1, water is acting as a Lowry-Bronsted base. And in the reaction number 2, I will explain that how water is acting as a Lowry-Bronsted acid. So in this reaction number 2, I will explain that how water is acting as a Lowry-Bronsted acid. Ammonia with one lone pair of electron is being reacted with water molecule to make ammonium ion and hydroxyl ion. Whenever ammonia comes in contact with water molecule releases its proton in the shape of hydrogen ion, you can call it, because ammonia has one lone pair of electrons, so it can make a bond with this proton released by water molecule. So ammonia forms a coordinate covalent bond with this proton and the molecule becomes like this. It adapts the shape of 4 hydrogen atoms and 1 nitrogen atom. This positively charged appear on the whole ammonium ion is due to the addition of positively charged particle to a neutral molecule of ammonia. Thank you for watching this video.